Hello students, welcome to another video. So this video I will be solving a previous year KTU problem. So this is from module 5 of MOS. This problem is from stress transformation portion of the module 5. So this is a Mohr circle problem. The problem was asked for 15 marks in December 2020. Okay. So at a point in strained material, the normal stress in two mutually perpendicular directions are 120 and 50 MPa. So 120 is tensile, 50 is compressive. The shear stress across these planes is 35 MPa. Find using Mohr circle the principal stresses and their planes, maximum shear stress and their planes. Okay, so this we have to use Mohr circle. I have drawn the stress block so to save some time. So this is x direction. I have assumed it to be 120 MPa in tensile, y direction 50 MPa in compressive, and there's a shear stress of 35 MPa. So in order to draw the Mohr circle, first we have to draw an axis system. So let's say I will draw an axis system here. Okay. Okay, so this horizontal is sigma axis. So sigma axis we have, if I divide by 10 MPa each, 10, 20, 30, 40, 50, 60, 70, 80, 100. Okay, this direction, minus 10, minus 20, minus 30, minus 40, minus 50. Then minus 60, minus 70, minus 80, minus 90, minus 90. Okay, and this is shear axis. Shear, clockwise shear we will draw in the top portion. Anti-clockwise shear we will draw in the bottom portion. Okay, so this will be anti-clockwise shear. So same values 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. Right. Now what we will do, so I'll just take this little down so that I can see this when I'm drawing the shear Mohr circle. So what I will do, I will take one side first. Let's say I will take this plane. So this vertical plane I will take. So in that plane, what we have is a 120 MPa tensile stress and a shear stress in this direction. So this shear stress is trying to rotate the element in anti-clockwise direction. So anti-clockwise direction we have to plot downward. Okay. So my stresses are 120 MPa tensile. So 100, 10, 20. This is 120 MPa. And anti-clockwise direction shear, which is of magnitude 35 MPa. So this is 10, 20, 30, 35. Okay. So this point is nothing but 120, 35. 35 is in anti-clockwise direction. So this is one point. For second point, I will consider this plane. So that plane, I am taking that plane. In this plane, we have a compressive stress of 50 MPa and a shear stress in this direction. Shear stress is trying to rotate it in clockwise direction. Okay. So compressive stress minus, so 10, 20, 30, 40, 50. This is minus 50. And shear is clockwise, so upward. So minus 50, 10, 20, 30, 35. So this point is minus 50, 35 MPa, which is clockwise shear. Okay. Now we have 2 points in the Mohr circle. These are nothing but these 2 points represent a diagonal, or it is lies on a diagonal. So I'll draw the diagonal here. So from this point to the center, this point. So this is diagonal of the Mohr circle. Okay. Now it is passing through the a point in the horizontal plane. So this is the center of the circle. What I will do, I will take a compass. I'll keep the compass in the center, exactly at the center. Try to keep it exactly at the center. Then I will measure, I will take the radius, this. Okay, I'll draw the circle. So let me draw the circle. Okay. So this is my circle. This circle is my Mohr circle. Okay. Now, if you observe in this circle, there are 2 points in which this circle represent the state of stress at different orientation. Okay. So the orientation which we have drawn is corresponding to this diagonal. What we have to find is we have to find principal stresses. Okay. So how do you find principal stresses? So in this circle, there are only 2 points in which shear stress is 0. So those point at this and this. Okay, so these 2 points in the circle has only normal stress. There is no shear stress. This higher value I'll call sigma 1. The lower value I'll call sigma 2. Okay, you can observe here the value of sigma 1 comes out to be this is 100, 10, 20, 128 something. Okay, 128 MPa approximately. 128 MPa, so approximately. Sigma 2 comes out to be it is minus 50, 58, 57 MPa. Okay, so approximately 57 MPa, minus 57 MPa. Okay, so this is the 2 values. Now, so this is first part, the principal stresses and their plane. Now, how do you find the principal plane? So to find the principal plane, you have to measure this angle. This angle. This angle is 2 theta. It is now we have to measure in anti-clockwise direction or counterclockwise direction 2 theta. Okay, so this angle we will measure. We will take up a protractor and try to measure this. So let's see. Keep it in the center. Okay, so this is around 23 degree, something around that. Let me see, 22, 23 degrees, so 22, so 22.5 degrees, something like that. Okay, so 2 theta is coming out to be 2 theta. So this is 2 theta p. 2 theta p is something around to be 22 degrees, 22.5 degrees. Okay, so theta p is nothing but 11.25 degrees. So this is the angle for principal plane. So first part is over, second part is over. Now what about third part? Third part, they are asking principal planes. So there are 2 possible principal planes. So one is this up to this point. Then we can also measure this also. What this one? This is also another principal plane. 2 theta p2. Okay. To get this value, either you use a protractor or you simply add. So any angle in this circle is half the angle in the real scenario. Okay, so here 2 theta p you have to add 180 degree for in the Mohr circle to get this angle. Okay, so 180 plus 2 theta p. So in actual case you have to add 90 degree. So second point is 11.25 plus 90 degree. Okay, so that just comes to be 101.25 degree. So this 2 theta p2 is nothing but 101.25 degrees. You can measure this also. So it may be this. So basically, what we have to do 180 plus 122.5 is this angle. Divided by 2 will give me 101.25. Okay, so that is also another way of doing it. So this we have found 2 planes, principal planes. Then maximum shear stress and their plane. Now, if you observe the point of maximum shear stress is you can observe here in this circle. The maximum value of shear stress will be at the top and bottom, somewhere here and here. Here and here. Okay. Okay, so to find that, I have to draw a line here, passing through the center. So this is the line. So those points are actually here. This and this. Okay. So this is the maximum shear. You can observe this value. What is this value? This value will be equal to, this will be equal to, the maximum value of shear will be equal to, so tau c max will be equal to the radius of the circle. Okay, so how do you find the radius of the circle? So if that's simple, sigma 1 we know it is 128, 128, and this point also we can find. So this comes over 10, 20, 30, 35. Okay, the center of the circle is at 35. This point, this distance is commonly known as sigma average distance. This is equal to 35 MPa. Okay, center of circle is at 35 MPa from the 0 point. So 35 and this is 128. So 128 minus 35 is the radius of the circle. So this comes out to be 128 minus 35. So this is 393 MPa, something around 93 MPa. Okay, it's approximately about 93 MPa is the shear stress coming. So this is nothing but the radius of the circle. And the angle for shear, again, this is the angle for shear, maximum shear. So this is this angle. So from this point to this is theta s, 2 theta s. So 2 theta s we can easily find. 2 theta s is equal to 90 plus 22.5. Okay, or theta s is equal to 22.5 plus 45, which is nothing but 67.5 degree. So this is one angle. So there is another angle. If you travel all around this, you'll get another angle. So basically you have to add 90 to this. So this first theta s, second point is 67.5 plus 90. Okay, so this is 157.5 degree. So this is 157.5 degrees basically up to this point, this line. Okay, the entire angle from here to here. So these are the two angles for principal maximum shear stresses. So I hope this is clear. There is a lot of information here. So once if you are familiar with drawing Mohr circle, this is an easy task. If you are not familiar, please practice more problems. Right now, so this is all they have asked from us. Now, what we can do is we can slightly deepen our understanding a little bit. What I'll do is I will rotate this. Okay, by what the angle? I will rotate by 11.25 degree. Okay, so this angle is 11.25 degree. So in this at this angle, what I will get is I have only two stresses. The value of those stresses is written here, sigma 1 and sigma 2. So this will be 128 MPa and this will be 57 MPa compressive. Okay, 128 and 57 MPa. So this is the meaning of this. If you rotate by so when you rotate 11.25 degree, you have to rotate 2 theta p degree in the Mohr circle, that is 22.5 degree in the Mohr circle to get this point. So if you draw the Mohr circle with respect to this, what you get is this diagonal. The starting point will be this diagonal. Okay, that for that Mohr circle. So if you had started with this diagram as the Mohr circle, first diagonal that you will be getting will be this. That is the point. Okay. Now again, if you rotate this further, so let's say if I again copy this. If I rotate this, let's say some more. I will erase. Okay, so this angle, if this angle is 67.5 degree, this is 67.5 degree. What you get? You get the plane of maximum shear stress. Okay, in the plane of maximum shear stress, the value of shear stress is given by the radius of the circle, which is approximately 93 MPa. So value of the shear stress is 93 MPa. Okay, and in this orientation, the maximum stresses. Okay, normal stress is nothing but sigma average, that is 35 MPa. It is both tensile. So this point is tensile, this point also this is tensile. So that means here the arrows are wrong. So what I am getting is 35 MPa tensile stress here, also a 35 MPa tensile stress here, okay. So this is the orientation, this is basically the stresses when we take a stress block with 67-degree orientation, okay. Now observe that this line, this block corresponding to the maximum shear, so this line. So if you had started with this, your initial problem, instead of this, if you started with this, the first diagonal that you will be drawing will be this, okay. If you had started with this, the first diagonal that you would have been drawing is this. Since you started with this, the first diagonal that you are drawn is this, okay. So that is all. This is what we get from the Mohr circle. So this is for maximum shear, this is for maximum sigma. I hope this is clear to you. You can also check these values. So this video is becoming very long, but you can also check these values analytically. So that also I'll just tell you. I will not solve this. These values will not exactly match because we are taking values from the graph. That is okay. So sigma 1, 2 equal to sigma x plus sigma y by 2 plus minus under root sigma x minus sigma y by 2 whole square plus tau xy whole square, okay. So this, if you do, you will get two values of sigma, that those values will be somewhere near to 128.10 minus 57 MPa, okay. And also you have to note that this value is nothing but sigma average. This is nothing but the radius of the Mohr circle. So sigma average is sigma x minus sigma y plus sigma y by 2. So in our case it is 20 minus 50 by 2. So that is 70 by 2, 35. So this is 35. Okay, so this is sigma average, this is radius. So this radius is also the same as the maximum shear stress, that should be equal to, so this value should be equal to 93 MPa. Okay, so there is a lot of information in this video. I hope you have understood the concepts. We will meet each other with another video. Thank you for watching.